What does it mean to be self-aware? To recognize oneself as an individual, separate from the world, separate from others. This question isn't just for philosophers. It's a deep scientific inquiry, one that takes us to the very nature of consciousness, a puzzle that humanity has pondered for ages, and one we are now exploring with new tools, across the vast tapestry of life and even beyond. For a long time, one test stood prominent, the mirror self-recognition test, or MSR. Imagine an animal, it sees its reflection. Does it know it's looking at itself? Pioneered by Gordon Gallup Jr. in 1970, he put a mark on an anesthetized chimpanzee, a mark it couldn't see without a mirror. Upon waking, the chimp saw its reflection. It touched the mark on its own body, a simple action, yet profound in its implication. This test became a benchmark, a kind of gold standard for animal self-awareness. Species that passed were thought to belong to an exclusive club: great apes, dolphins. The mirror test was revolutionary, no doubt. It gave us a starting point, a way to ask the question, but science never stands still. It questions, it refines. And soon, questions arose about the MSR test. What if an animal is incredibly intelligent? What if it possesses a rich inner life? Yet it fails this specific visual test. Does that mean it lacks self-awareness entirely? Or does it mean our test is too narrow? Perhaps the mirror doesn't reflect everything. Consider dogs, our loyal companions. They show complex emotions, they solve problems. They understand our cues, our moods. Yet most dogs don't pass the standard MSR test. They might react to the mirror image as another dog or simply ignore it. Gorillas too have shown mixed results, despite their clear intelligence and close relation to us. Some pass, some don't. Why the inconsistency? And what about highly social birds with complex behaviors? The criticisms of the MSR test have grown. One major issue, its heavy reliance on visual perception. Imagine a world painted not in light but in scent, or a landscape sculpted entirely by sound waves. Our human experience is dominated by vision. It shapes how we think, how we interact. But the universe of sensory experience is far grander. Many creatures navigate their reality using different toolkits. Their Umwelt, their perceived world, is alien to ours. And so their sense of self might be built on different foundations. Foundations our vision-centric tests might miss. This is a crucial realization for science. Think of a bloodhound, its nose a marvel of biological engineering. It can follow a scent trail days old, miles long. Its world is an intricate map of odors. What would a mirror mean to such a creature? Would it be a surface reflecting light? Or perhaps a unique olfactory signature? Bats paint their world with echoes, navigating pitch-black caves with astonishing precision. Their reality is a symphony of reflected sound. A visual mirror is largely irrelevant to their primary mode of perception. The MSR test, by its very design, favors animals that are 1. Highly visual, 2. Have the motor skills to touch a mark, and 3. Are curious enough about a strange mark on their body. If a species doesn't tick all these boxes, it might fail. Let's dive into the ocean, a world of blues and grays, but also a world filled with sound. Here swim the dolphins, highly intelligent, socially complex, among the first non-primates to pass the MSR test. Their visual acuity is good. They are curious creatures. They investigated marks on their bodies using mirrors. This was a landmark discovery, confirming their sophisticated cognition. But dolphins live in an acoustic world as much as a visual one. Sound travels far and fast underwater. Could their self-awareness also have an acoustic dimension? Dr. Diana Rice, a pioneer in dolphin cognition, explored this. She and her colleagues wondered, if dolphins recognize themselves in a mirror, could they recognize themselves through sound? Dolphins use signature whistles, unique calls, like names identifying individuals within their pod. These whistles are crucial for social cohesion, for mother-calf bonds. What if a dolphin heard its own signature whistle played back? Would it recognize it as me? This question opened up a new avenue of research, beyond the visual, into the realm of sonic identity. The experiments were ingenious. Researchers played back a dolphin's own signature whistle, and also the whistles of familiar and unfamiliar dolphins. Section 5. Feathered minds, corvids, and the depths of avian cognition. Dismiss the term bird-brained. It's an insult to birds, especially to one group, the corvids. Crows, ravens, jays, magpies. These are not your average feathered friends. They are the Einsteins of the avian world. Their cognitive abilities are astonishing, challenging our old assumptions about intelligence, and just maybe about self-awareness. Their brains may be small compared to ours, but they are incredibly dense with neurons, packed for power. Professor Nicola Clayton at the University of Cambridge. Her work has revolutionized our understanding of corvid minds. She's shown that some corvids, like scrub jays, plan for the future. They cache food, not just randomly. They remember what food they hid, where, and even when. Crucially, they also seem to know if another bird was watching them. If they were observed, they might later re-hide their stash. This suggests a kind of theory of mind, an ability to understand the mental state of another. That's a sophisticated cognitive skill. Corvids are master problem solvers. They can use tools, even make tools. Section 6. Tentacled thinkers, octopuses, and the scent of self. Prepare to meet an intelligence utterly alien to our own. Descend into the ocean's depths, to the realm of the octopus, a creature of profound intelligence with an ancient lineage, separated from ours by hundreds of millions of years of evolution. Its mind is organized so differently, a large donut-shaped brain around its esophagus, and 2/3 of its neurons distributed in its 8 arms, each arm capable of independent action, yet coordinated. How does such a being experience self? An octopus is a master of camouflage, skin like a living screen. Vision is clearly important to it, but it also lives in a world of touch and taste. Its suckers can taste what they touch. Its primary sense of the world might be a chemosensory tapestry, a symphony of molecules dissolved in water. So, would a visual mirror test capture its essence of self? Perhaps, but perhaps we need to think about other senses. What about the scent of self? Could an octopus recognize its own chemical signature? Researchers have begun to explore this fascinating idea. Experiments have been designed with elegant simplicity, presenting an octopus with different chemical cues, the scent of an unfamiliar octopus. Section 7. The algorithmic on-probing self-awareness in artificial intelligence. Now, let's shift our gaze from biology to bits, from flesh and blood to silicon and code. We enter the realm of artificial intelligence, AI, machines that learn, machines that create, machines that are increasingly integrated into our lives. This raises a profound, almost philosophical question. Can an AI be self-aware? Can a construct of algorithms and data possess a sense of I? The question itself marks a new frontier in science, and it demands entirely new ways of thinking about testing. The traditional mirror test, designed for animals, it doesn't quite make sense for an AI. An AI doesn't typically have a physical body in the same way. It doesn't look into a physical mirror to see a mark. So how do we even begin to approach this? We can't simply ask the AI, "Are you self-aware?" The answer might just be what it's programmed to say, or what it has learned is the most human-like response. We need more objective, more insightful measures. Measures that probe the internal workings of these complex systems. Researchers are developing innovative methods. They are looking for something beyond mere intelligence, or the ability to mimic human conversation. Section 8. Metacognition in machines AI. Knowing what it knows. Metacognition, a fancy word, but a simple idea. Thinking about your own thinking. It's what allows you to realize you've forgotten someone's name, or to feel confident that you know an answer, or to decide you need to study more for a test. In humans, metacognition is a cornerstone of higher awareness. So, can we find evidence of metacognition in machines? Can an AI demonstrate this ability to self-reflect? They can monitor their own performance on tasks. They can assess their level of confidence in a decision they make. But also, I'm 95% sure that's a cat, or I'm only 40% sure I might need more data. This ability to express uncertainty is a form of metacognitive judgment. Section 9. The ethical compass, redefining our relationship with aware beings. Why this relentless quest? Why do we strive so hard to peer into the minds of animals, or to assess the nascent self-understanding of AI? Is it mere scientific curiosity, a cosmic game of peekaboo? No, it's much more than that. The search for self-awareness and how we measure it has profound ethical implications. It shapes how we see other beings, and ultimately how we treat them. Our understanding directly influences our moral compass. Expanding our toolkit for testing self-awareness is vital. When we discover that dolphins recognize their acoustic self, or that corvids plan for the future, or that octopuses might know their own scent, it forces us to reconsider their place in our moral landscape. These findings can fuel changes in animal welfare laws. They can influence conservation efforts. If an animal is demonstrably more aware than we thought, doesn't that demand greater care, greater respect, greater protection? Our science informs our ethics guide our actions. And what about artificial intelligence? Section 10. The quest continues, charting the future of consciousness research. Our journey into the vast landscapes of self-awareness. It is far from over. We stand like explorers on the shore of a great uncharted ocean. The tools we have now are like early rudimentary vessels. They've taken us to fascinating new lands of understanding. But the horizon of mystery still stretches out before us. The quest to understand consciousness in all its forms is one of science's grandest challenges. Future research will demand more creativity, more innovative tools and methodologies. Tests must be tailored to the specific sensory world of a species and to the unique architecture of an AI system. We must guard against our own human-centric biases. The universe of mind is likely far more diverse than our current imagination can fully grasp. We will see more interdisciplinary collaboration. This is not a puzzle for one field alone to solve. Neuroscientists mapping the brain's intricate pathways, ethologists observing behavior in natural and controlled settings, computer scientists designing and probing AI.